This video clip is part of the EPFL Introductory course on Information Computing and Communication. It is the 8th one in a set of clips on computer communication and networking. It gives a very brief overview of the role and function of some of the most important Internet protocols. As mentioned earlier, the main Internet Transport Layer Connection Protocol is TCP, the Transmission Control Protocol. TCP is precisely concerned with managing transport connections between communicating computers from end to end, so that the intermediate routers are completely relieved from this overhead and can just focus on routing packets as fast as they can, leaving the TCP end connection implementations in the computers communicating from the edges of the network. So they have to worry about addressing sequencing, flow control, error recovery, etc. A TCP connection is opened by an exchange of connection setup messages and closed by an exchange of connection teardown messages. In between those connection and disconnection messages, all TCP packets do carry sequence numbers, unlike IP packets, which don't. That way, TCP can detect when packets may arrive out of order or be missing and need retransmission. It can also adjust the flow control window so as not to overwhelm the intermediate IP routers by sending packets faster than the receiver can take them. When an application message is too large to be sent in a single packet, TCP is able to chop it up into several IP packets on the sender side and reassemble these into original messages on the receiver side. A TCP connection stretches between two computers, but there can be multiple applications on any computer. These applications are referred to by their own internal addresses, unrelated to the IP addresses. Those internal addresses are called port numbers and are recognized and distinguished by TCP. A protocol called SSL, Secure Session Layer, also standardized under the name of TLS, Transport Layer Security, is a secured version of TCP. It will be briefly discussed in the ICC video clips on IT security. At the application layer, one of the most important Internet protocols is the Domain Name System, DNS, which translates Internet application names such as www.epfl.ch into IP addresses understood by Internet routers. In that sense, DNS is the protocol for accessing what amounts to the Internet phone book. Of course, on Internet, as in real telephone networks, there is not one single phone book covering the whole world. Instead, just as phone books are divided into countries and regions, DNS defines a hierarchy of application names. At the top level of that hierarchy, it defines 20 naming domains such as com for commercial sites, edu for education, and org for organizations. These naming domains are defined and are managed essentially in the US. But in order to allow other countries to manage their own application names, DNS also defines 248 two-letter country domains such as CH for Switzerland. Within any such top-level domain, the domain managers are then free to define application names as they like within their country. As shown on this picture, some named applications may appear in different domains under different names. For instance, www.google.ch and www.google.com are indeed conceptually the same Google search application that we all know. Those names may and typically do, however, translate into different IP addresses corresponding to different server computers. Indeed, google.com may serve primarily customers in the US, while google.ch is meant primarily for Swiss customers. Therefore, they serve different ads in different languages. Domain names such as .com and .ch say, however, nothing about where the corresponding servers are located. Just because a server bears a name ending in .ch does by no means imply that this server is in Switzerland. It may be anywhere in the world, but just registered with the Swiss.ch domain, as well as in other domains, or maybe not. Every DNS domain must provide at least one server, that is, one online phone book, for names in its own domain. For availability and reliability reasons, it should preferably offer 2 or even more servers with replicated copies of the same phone book. The top-level DNS servers reside at 13 well-known and fixed IP addresses so that any computer in the world can locate them. Actually, for performance and reliability reasons, more than 500 physical servers operate behind these 13 IP addresses, some of them sharing the same IP address. The hundreds of servers bearing one of these 13 IP addresses provide the IP addresses of all of the top-level domain phone books. Then the .ch phone book, for instance, provides the IP addresses of the phone books for each of the subdomains in Switzerland. So, for instance, it advertises the IP address of the EPFL phone book, presumably located at EPFL, although not necessarily so. Similarly, the .com phone book provides IP addresses for IBM and Google phone books, and so on. That way, any application on any computer in the world, anywhere, can always find out the IP address of any other application in any other computer anywhere else in the world, by first querying one of the top-level DNS phone books and then recursively querying lower-level phone books until they hit the one containing the IP address that they're looking for. The practical implementation of this is again way more complicated than just explained, but the hierarchical principle is exactly as we discussed it. The Hypertext Transfer Protocol, HTTP, is the application protocol for surfing the web. It provides essentially 4 types of messages. Post, which creates or adds an information onto a web server. Get, which retrieves and returns an information from a web server. Put, which updates or eventually creates an information on a web server. And delete, which, as the name suggests, deletes an information on a web server. On any of these messages, the target information on the target web server are designated by so-called URIs, Universal Resource Identifiers, which are character strings of the form syntax indicated on this slide. The server is the DNS name of the computer hosting the desired website. The port, if present, designates the web application on that server computer. By default, it is port number 80 for web surfing. The tree name, if present, designates a file to be fetched or a program to be executed inside the target web application. And the parameters, if present, specify any details concerning the requested file or program, for instance, a value to be stored into or type of information to be retrieved from the target resource. A URI specifying HTTPS instead of plain HTTP indicates that the HTTP protocol should be used over the SSL or TLS secured version of TCP for added security. Inside HTTP requests and responses, all resource content information must be expressed in the HTML language, the hypertext markup language. The last important application layer protocol on Internet is email. The main protocol for such applications is the Simple Message Transfer Protocol, SMTP. It allows delivering email messages from sender mailboxes to recipient mailboxes. Recipients must explicitly consult their mailboxes to retrieve their mail, as on webmail servers. If a recipient prefers to read her mail offline on her own computer, tablet, or smartphone, then she must first download the content of her mailbox from the SMTP server to her local device. For this, she can use either the Post Office Protocol, POP, or the Internet Message Access Protocol, IMAP. Both allow the user to maintain a second mailbox on her personal device, in addition to the one on the mail server. With POP, the user manages the mailbox contents herself, so some messages may remain in one mailbox while they're deleted from the other. With IMAP, the two mailboxes are synchronized, so their content remains identical at all times.